use the phrase quantum leap all the time. A quantum leap in your career, a quantum leap in income, a quantum leap in consciousness. It sounds dramatic, sudden, explosive. But here's the strange part. In physics, a quantum leap does not mean massive. It does not mean magical. And it certainly doesn't mean you jumped timelines. In fact, the original meaning is far more precise and far more unsettling. A quantum leap is what happens when an electron moves from one energy state to another. Not gradually, not by sliding, not by passing through every possible point in between. One moment it is here, the next moment it is there. No visible transition, no intermediate state, just a jump. And that discovery changed science forever. At the end of the 19th century, physicists believed nature was continuous. Energy flowed smoothly, like water pouring from a jug. Change was gradual, predictable, linear. Then, in 1900, Max Planck made a desperate move while trying to solve the problem of blackbody radiation. He proposed that energy does not flow continuously. It comes in discrete packets. He called them quanta. Planck himself thought it was just a mathematical trick, but Albert Einstein took it seriously. In 1905, he used the idea of energy quanta to explain the photoelectric effect, showing that light itself behaves as if it comes in packets. That paper later won him the Nobel Prize. Then Niels Bohr applied quantization to the structure of the atom in 1913. He proposed that electrons orbit the nucleus only in specific allowed energy levels. They cannot exist between them. If an electron absorbs energy, it jumps up. If it releases energy, it jumps down. No sliding, no half measures. And that jump, that discontinuity, became known as a quantum leap. Werner Heisenberg later formalized the mathematics of this strange world with matrix mechanics. Erwin Schrödinger developed wave mechanics. Together, they built quantum mechanics, a theory that replaced smooth certainty with probability and sudden change. But here's what matters. Quantum leaps are not chaotic. They are lawful. An electron does not randomly teleport. It jumps when specific energy conditions are met. When the system reaches a threshold. That's the part people forget. A quantum leap is not about speed. It is about structure. It is what happens when a system can no longer remain in its previous state. Now pause. Because this is where physics quietly rewrites how we think about transformation. In everyday life, we assume growth must be gradual, linear, step by step. But nature does not always evolve that way. In thermodynamics, systems undergo phase transitions. Water heats slowly, molecule by molecule gaining kinetic energy, and nothing dramatic appears to happen until 100 degrees Celsius. Then suddenly, water becomes steam, a structural reorganization. The work of physicist Ilya Prigogine on dissipative structures showed that complex systems, when pushed far from equilibrium, do not simply break down. They reorganize. Suddenly. In neuroscience, similar principles appear. The brain rewires gradually through synaptic plasticity, studied extensively by researchers like Donald Hebb and later Eric Kandel. But insight itself can feel instantaneous. Years of subtle neural restructuring, then a breakthrough. In complexity science, these are called tipping points. In physics, they are critical transitions. In quantum mechanics, they are jumps. And this is the deeper scientific meaning of a quantum leap. It is discontinuous change triggered by accumulated conditions. Not magic, not fantasy, structure. Now here's something even more fascinating. When Schrödinger wrote down his famous equation in 1926, it described the smooth evolution of a wave function, the mathematical description of a quantum system. But when we measure that system, we don't see smooth evolution. We see a jump, a discontinuity. This tension between smooth underlying equations and sudden observable change is still debated today. Physicists like John Wheeler later described reality as participatory. The act of measurement plays a role in how possibilities become actualities. The leap is not visible until interaction occurs. That idea unsettled even Einstein, who famously said, "God does not play dice," but experiments, from the double-slit experiment to modern quantum optics, continue to confirm that at the smallest scales, reality does not move continuously in the way our intuition expects. It reorganizes in discrete states. Now bring this back to the phrase we casually use. When people say quantum leap, they mean dramatic improvement. But the real physics is more interesting than that. A quantum leap happens when enough energy accumulates within a structure that the old configuration becomes unstable. And instability is not failure. It is preparation. Systems resist change until they cannot. Then they shift. Not halfway, not tentatively, but fully. And here's the quiet scientific insight hidden inside that. Most transformation is invisible before it is visible. Electrons absorb energy quietly. Water heats molecule by molecule. Neural networks strengthen connection by connection. Then, threshold. Then, leap. The transformation looks sudden, but it was structurally prepared. This is not motivational language. It is physics. The mathematics of quantum mechanics, the thermodynamics of phase transitions, and the science of complex systems all converge on the same principle. Change is often nonlinear, and nonlinear change feels sudden, which means something profound. Sudden transformation is not irrational. It is natural. The real question is not whether quantum leaps exist. They do. The real question is whether we misunderstand what prepares them. And once you see that, something changes in how you interpret your own life. Because if sudden transformation in physics is not magic but threshold dynamics, then maybe the same pattern operates in complex human systems. Let's be clear. You are not an electron. Your career is not an atom. But you are a biological system, and biological systems obey nonlinear dynamics. Your brain does not change in a straight line. Neuroplasticity research, beginning with Donald Hebb's principle, neurons that fire together wire together, shows that change in the brain accumulates through repetition and reinforcement. Synaptic connections strengthen gradually. Circuits reorganize slowly. But behavior does not always appear gradual. One day you tolerate a situation. The next day you can't anymore. One day you feel stuck. The next day you resign. One day you struggle to run 5 minutes. 6 months later, you complete a marathon. The visible moment of change feels sudden, but the structural preparation was slow. Eric Kandel's Nobel Prize-winning research on memory formation showed that learning physically alters synaptic strength. Proteins are synthesized. Connections are stabilized. Structural changes occur at the cellular level, but you don't feel proteins being built. You feel the breakthrough. That's the same pattern as a quantum jump. Invisible preparation, visible shift. Now let's go deeper. In complexity science, systems often reach what is called a critical point. This has been studied in fields ranging from physics to ecology to economics. At a critical point, small inputs suddenly have large effects. Before the threshold, effort seems ineffective. After the threshold, change cascades. This is sometimes called a phase transition. Think of relationships. You don't wake up one morning randomly in love, or randomly disconnected. Micro-interactions accumulate. Trust builds or erodes. Conversations strengthen or weaken bonds. Emotional patterns repeat. For months, maybe years, nothing dramatic seems to change. Then one day, something shifts. A proposal, a breakup, a redefinition. From the outside, it looks sudden. But relational systems reorganize just like physical ones. Threshold. Leap. Now consider work. Career transformations often appear abrupt. Someone launches a business overnight. Someone leaves a stable job and pivots industries. Someone steps into leadership. But behind that leap are accumulated competencies, network effects, skill acquisition, internal identity restructuring. Sociologist Mark Granovetter studied the strength of weak ties and showed that opportunities often emerge through subtle network connections that accumulate quietly before becoming visible shifts. The leap is rarely impulsive at a structural level. It is the point where internal and external variables align. And health? The body is also nonlinear. Weight gain doesn't always happen smoothly. Autoimmune conditions often emerge after prolonged stress exposure. On the positive side, metabolic improvements can reach tipping points where insulin sensitivity dramatically improves after consistent habit restructuring. Research in systems biology shows that the body operates through feedback loops. Small adjustments accumulate. Then the system stabilizes at a new level. This is not motivational theory. It's regulatory dynamics. The same pattern appears in wealth. Compounding, studied mathematically since Jacob Bernoulli formalized exponential growth, looks boring at first. 1% growth seems trivial. 5% growth seems slow. But nonlinear growth curves eventually bend sharply upward. The leap appears dramatic at the end, but it was mathematically inevitable once momentum crossed threshold. This is where misunderstanding happens. People want the leap without respecting the accumulation. They want the visible jump without the invisible energy absorption. But physics teaches something uncomfortable. Energy must be absorbed before the electron jumps. Stress must build before a phase transition. Synaptic reinforcement must occur before insight. Preparation is not glamorous. It is structural. And here is something even more subtle. Instability is not always a sign of failure. In physics, systems become unstable before reorganizing. Near a phase transition, fluctuations increase. Noise increases. Variability increases. Before water boils, bubbles form unpredictably. Before a neural breakthrough, confusion increases. Before a relationship shifts, tension rises. Before a career pivot, dissatisfaction grows. We misinterpret instability as collapse, but often it is reconfiguration. Ilya Prigogine showed that systems far from equilibrium can self-organize into higher-order structures. Dissipative structures, like hurricanes or biological organisms, emerge because of instability, not despite it. This reframes something powerful. Discomfort may signal that you are near a threshold, not because the universe is conspiring mystically, but because systems reorganize under pressure. Now let's be careful. Quantum mechanics does not say you can manifest an electron jump through intention. It says systems change state when energy conditions are met. So how does this translate responsibly to human life? It means your leverage is not in forcing leaps. It is in managing input variables. In relationships, that means consistent communication patterns. In career, that means skill stacking and exposure. In health, that means repeated metabolic regulation. In wealth, that means compounding discipline. The leap is the visible outcome of structural coherence. There's another insight from quantum theory that matters here. Quantum systems occupy discrete states. They cannot exist between energy levels. That means when transition happens, it is complete. An electron doesn't half jump. When your identity reorganizes, when you truly internalize a new self-concept, the shift can feel sudden and total. Psychologist Carol Dweck's work on mindset shows that identity-level beliefs govern behavior patterns. Once someone shifts from a fixed to a growth mindset, performance trajectories change non-linearly. It's not incremental confidence. It's a structural reframing. And identity shifts are often threshold events. Years of doubt. Then one reframing conversation. Years of hesitation. Then one decision. Years of preparation. Then one move. The leap is not randomness. It is convergence. Now let's bring it back to physics one last time. The Schrödinger equation evolves smoothly. The wave function spreads continuously. But measurement reveals discrete outcomes. In life, preparation is continuous. But action is discrete. You prepare continuously. You act in leaps. You accumulate. You decide. You absorb energy. You change state. And here is the grounded truth. You cannot skip preparation. But you can recognize thresholds. You can notice when dissatisfaction is not weakness, but signal. You can notice when tension is not failure but instability before reorganization. You can notice when boredom signals readiness for a new state. And instead of resisting instability, you can ask, what system variable is reaching critical mass? What inputs have I been accumulating? What state is no longer sustainable? A quantum leap is not fantasy. It is structured transformation. And when you understand that, you stop chasing miracles. You start engineering thresholds. You stop waiting for dramatic rescue. You start absorbing the right kind of energy. Because sudden transformation is not about escaping your current reality. It is about reorganizing it. Not through wishful thinking, but through alignment between accumulated effort and structural readiness. In physics, nothing jumps without cause. In life, nothing stabilizes without preparation. And when preparation meets threshold, the leap feels instant. But it was built all along.